So I will tell you, I couldn't just call my charts digital transformation because I knew that's what everybody's charts would be called. So I came up with dial-up of things as my initial roll-in. So first I'll tell you, I love this aircraft. If you don't know this aircraft, it's the C-130J. It is the second longest production aircraft in the world. It's been continually produced since 1954. What I will tell you, saying that, there is no digital twin for that aircraft. We're trying, but there are parts on that aircraft that are the same design as the aircraft in 1954. That design is rolled up in the basement of a building in Marietta, Georgia, that's also a nuclear fallout shelter. So if you feel that stuff's coming, come on down to Marietta, we've got the space. To tell you a little history about myself, I started with Lockheed in 1992, had finished a grad degree in mathematics, came in and worked for the reliability engineering team. I actually left in 99 and started a healthcare software company with a friend of mine and a local cardiac surgeon. As part of that, I really started to get to use more of my mathematics and analytics background. Was lucky enough to be published in a couple of medical journals dealing with survival analysis. Then Lockheed decided they wanted to start getting more into big data. They reached out to me to come back and start up their data analytics team for the C-130. Let's see, I haven't seen how this, there we go. So this is what I walked into. Also, if you listen to what I said about my background, you never heard me say that I took a PowerPoint class. So when you become an LM fellow at Lockheed, nobody works for you anymore. You get paid to think. So I have nobody I can call up and say, I need you to create some charts for me. When I mentioned it to the executive assistant in our area, she just kind of laughed me off. So these are my charts. I did this. Apologies ahead of time. So when I walked back into this, I was in that box at the top, the data analyst box. I was the data analytics department. And the way it all worked is I called the guy in the LM data center, told him I need this data. He connected to the actual customer database and pulled down a little snippet that was supposed to answer my question. And then other internal customers would call me and say, what did that little snippet tell you? And then the external customer would call me, what is our data telling you? And it was all backwards facing. I was telling you what happened 3 months ago and why it happened, but I wasn't helping you get ahead of the problem. So my solution was to focus on how do I let you know what's coming down the line on an aircraft that is a first generation aircraft. So that aircraft, like I said, it's originally built in 1954. When we built the J, we added some sensors to it. Everybody thought that was the greatest thing. We added sensors. But big data wasn't a thing when we built the J. It rolled off the line, the first one in 98. And so there's a little card on the aircraft that captures 30 megabytes of data per flight hour. That's the maximum it'll hold. So that was where we started. So then, can you tell my SAS representatives in the meeting with me? So I wanted to see what is all the data that's out there, because really early on we were just looking at maintenance data, repair data, no sensor data coming off the aircraft. So this became the start of our solution. How do we go out and find all this data? And then what can we do with it? So I'll tell you the first step for me, most aircraft programs, for example, the F-22 has one customer, one data system. It all comes in looking exactly the same. I have 23 customers now. Some of them keep their maintenance records in a handwritten flight log that I have to translate from another language when I get it back in. Some of it's in Excel spreadsheets. Some of it doesn't exist at all. So that was the first question we had to answer. How do we get this data in? How do we clean it up? And even when we look at our largest customer, which I'm sure you can guess who that is, they have 18, 19-year-olds out there. It's their job to fix the aircraft and enter the data into the system. when they finish fixing the aircraft, the priority of getting the data in system is not their top priority. Their top priority is getting a beer at the end of the day. So our first job was to use SAS analytics to develop the text analytics machine learning algorithm to help us clean the data. So I'm sure all of you know the first thing in any digital transformation is making sure the data is correct, and it wasn't. For example, there's a $500,000 computer on the C-130J. The first anomaly we detected in looking at the data was that they had replaced 6 of them in one day on one aircraft. Well, there's only 2 on the aircraft. What they had actually done was when they get a failure, they'll swap them and see if the failure still occurs. But every time they swapped them, they put in the data record that they'd replaced it. So if I'm basing how many spares I'm going to purchase on that, I've just bought 6 extra $500,000 computers. So that was our first step, clean up the data. And originally it was painful and it was manual. And I had 2 guys that were ex-maintainers that all they did was sit all day and clean data. So we built some machine learning algorithms. We've got the data now where we can get about 85 to 90% accuracy without ever looking at the data manually. So the next step was then use that data to build out models to help us build this analytics engine that would help us tell the customer, here's what's coming for you, not what's happened in the past. Here's the problem that's facing you next. And then this becomes, in the long term, a supply chain answer for them. Because what I ultimately want to do is, you see the arrows going this way, they have to go both ways. So there's now no digital twin for this aircraft, but there is a digital sustainment thread. So that data is flowing back and forth. I can build out a logical digital twin for the aircraft and start seeing how those parts perform. And then feed that out both internally and externally. So the first tool we actually went out with, and what we've developed is a analytics as a service for our customers, so that we can put this machine learning algorithm out on their servers. The aircraft's going to land, and again, not a PowerPoint guy. So it's a picture of a C-130 up in the corner. When that aircraft lands, data comes off in a couple of different ways. There's a debrief file that tells them what faults happened while the aircraft was flying. There's also a trend file that tracks some of the sensor data, not much of the sensor data, 30 megabytes of it. So our first process, we started building out models that blended that together, looked at what fault codes they got, looked at what they did when they got those fault codes. Did they go out and replace a part? Did they troubleshoot it? Did they fix wiring? And then we started learning from that. Because once they go out and take that part off, it's going to go back to the maintainer. The maintainer is going to either fix the part or tell them they couldn't find a problem with the part. So then that learning engine starts telling them, well, we see that you took this part out, but 80% of the time when you send it back, the vendor can't find a problem with it. So we've started building basically a knowledge base that's machine learning and telling them better ways to maintain their aircraft. What that gives them is more availability of the aircraft, more time they can be flying the aircraft. And that's continuously learning as it processes through, and not just from one customer, but from every customer that allows us to get the data. The next step, and I'm sure some of you know the term CBM Plus, Condition-Based Maintenance Plus, which there's a lot of arguments what the plus means. To me, it means more sensor data. So we've then looked at, okay, can we use this data to tell the customer the health of that aircraft, the health of those parts at any given time? So the next piece of our tool was this fleet health monitoring tool that tells them, for an aircraft, for the fleet, what is the health of that aircraft currently? What are the problem children on that aircraft? Now, at this point, the customer has a decision to make. They can do condition-based maintenance or they can let it fail. But it's actionable information. Where we see it being used the most is, let's say I've got to pick 4 of those aircraft to send on deployment, and I need to know which spares to take with me. There may be things in that tree, so if you look at the tree, it's telling me the things that are reddest are the ones that are closest to failure. The bigger the box, the longer it takes to repair it. So I may not want to take an aircraft that has a part that's about to fail that may take 2 days to repair. I want to take a different aircraft. Or it may be that that part's about to fail and I normally wouldn't take it with me when I go. So it's actionable information for them to better determine how to maintain that fleet. And this will get back around to manufacturing digital transformation. So I know most of what we have here is manufacturing, but this is key for us in supply chain to get us back to the value of having that digital transformation across the corporation. There we go. So then I've been doing this for, at the time that we delivered those tools, I've been doing it for about 4 years. When we started, I was the only person doing it. Now I have a department of about 8, just focused on the C-130. We've now applied some of the things we learned to the F-35, to the U-2 program, to the F-22 program, and we're seeing that footprint grow. But then after, like I said, after doing this, I find out, guess what? The aircraft generates 3 gigabytes of data per flight hour. I'm getting 30 megabytes when the aircraft lands. So this is where the real digital transformation comes in. I need this aircraft to tell me more. So a year and a half ago, we worked with our aircraft test team to develop a data bus recorder to put on the aircraft to give us all that information. And we found some amazing things. You know, the aircraft could start telling us, hey, I'm having problems, long before those problems hit. So we did that for a year with one of our customers, gathered that data, built some algorithms. Now we're working with our advanced development programs. We've developed a whole new system that will now go on all newly delivered aircraft and can be retrofitted on old aircraft that will take this analytics and bring it on board. Through event stream processing, we're going to watch that data as the aircraft flies, and we can radio ahead to the maintainer to say, here's what's coming at you, be ready for it. Now, on new aircraft liners, that's standard. On an aircraft that started in 1954, it's not. And so now we've gone back to the manufacturing side and said, not only do we need to put this new equipment on board, we need new sensors. We need more data coming off the aircraft so that we can help our customer better maintain the aircraft. Now the question is, can I get my video to play? So what we did to prove out the concept is we tried to find certain failures on the aircraft that we could detect while the aircraft was still in flight. So we developed some anomaly detection engine. And yep, there it goes. So we used an SBDD model for this. We set a baseline of what normal behavior looked like. I will tell you, this aircraft did not originally fly in Marietta, Georgia. I have to mask that information of where the aircraft actually flew. So then you can see there on the lower left-hand side, it's detected an anomaly in that sensor behavior. And what we were able to confirm with the engineers that own these systems is when that aircraft landed, it was going to tell you there was a fault. But now, 2 hours before it lands, I can let the maintainer know that there's a fault and radio that ahead. Now, that's on board. After the aircraft lands, I want all that data because now I want to see, can I see other systems that are getting close to failure, maybe 50 flight hours, 100 flight hours, so that customers can actually, if they want to do CBM Plus, they can do that. They can replace parts before they fail, reduce their downtime, and improve availability. So I was told, give us some examples of how this has been beneficial. So here's the interesting thing when you deal with a government customer. The government customer doesn't make revenue, not through the airplane, through us, but not through the airplane. So if you look at someone like Delta Airlines doing CBM Plus, they improve their availability, they improve their on-time departures, they improve their brand. So we have to look at it in terms of how can we improve the performance of our customer doing the important jobs they go out and do. So increased availability and mission readiness is the first. And you see that when you have disasters like you have now in Turkey, where C-130Js are going out to deliver relief in that situation. We want those aircraft ready to fly. They're going to be able to turn the aircraft faster, do the maintenance faster, reduce repair costs. That's a savings for everyone in this room. If they're paying less for repairs in the government, it's saving us money. And then the right spare, right place, right time. It is key to our customers that supply chain be resilient and fast. If they're going to have a failure tomorrow, that part has to be there for them to fly that aircraft. So through all of this, there is not necessarily a huge financial number I can say, hey, look what we saved. But there are missions flown, lives saved that we show through what we do for the C-130. I will tell you one other thing real quick about the C-130. If you haven't seen it, so the C-130 can take off and land in next to nothing. So one, go to YouTube and look for C-130E lands and takes off from an aircraft carrier with 3 JADO bottles strapped to the side of it. Could not have paid me enough money to be on that airplane. And then our test pilot, who just recently retired, looped a C-130J at an air show in Europe right before he retired. Go out and search that, and you'll be amazed that the wings didn't rip off that airplane. So, but thank you for your time, and I'll take questions.